Welcome. My name's Hamish Mackenzie, and thanks for joining us for the next session at IIoT World Energy Day 2026, Turning Industrial Data into Energy Insight, Scalable Edge Solutions for Modern Grids, sponsored today by IoT Systems. First off, it would be great if you could just tell us who you are, where you are. We like to get a feel for who's joining us in these sessions. And while you do that, get settled in, I'll just give you a little bit of housekeeping, as I always do. As I'm sure everybody knows, this is going to be an hour-long session. I'm going to introduce the topic, our guest speakers, and we're going to be getting a lot of valuable insights from them, of course. But we also want to try and leave time for you, the most important people in the room, of course, our audience. This is who we're doing this for. You are who we're doing this for. So please do get your questions in throughout the session into the Q&A function in the platform. Don't put them in the chat. If you put them in the chat, there's a pretty good chance I'm not going to see them. So if you can use the Q&A function, that would really help me a lot and make my life a lot easier. And we really do want to try and get to some of those at the end. It's sometimes a challenge because there's so much to talk about with all of these topics, but we'll do our best. All right, so time to focus on this session then. As modern grids absorb unprecedented volumes of data from battery systems, solar, wind, EV charging, and other distributed energy resources, the industry faces a critical challenge, and that is how to transform raw industrial data into real-time operational intelligence. And so we're going to be looking at how the shift towards decentralized software-defined energy systems demands high-performance edge platforms capable of unifying diverse protocols, executing analytics at the point of control, and scaling across thousands of assets, and how to make that happen in the real world. And to help us do that, I'm delighted to say we've got 4 very special guests with us. So I'll just introduce all of them to you now. First of all, we have Andrew Foster, who is Product Director of IoT Systems, our sponsor today. He has over 25 years of experience in developing IoT and distributed real-time and embedded software products. He's a co-founder of the company, and he's helped build one of the industry's leading-edge computing platforms. Technology designed to integrate, normalize, and process industrial data at the edge for mission-critical systems. And he frequently presents at distributed computing, middleware, edge architecture, IoT technology, those kind of topics. He holds a master's in computer-based plant and process control and a bachelor's in digital systems. So thank you very much for joining us, Andrew, and for sponsoring the session, of course. Then we have Brenna Wood, Senior Group Product Manager at EDF Power Solutions North America. And Brenna is an accomplished product management leader with over 20 years experience of driving digital transformation. She specializes in technology assessment for real-time operations and SCADA systems, managing 16 gigawatts of power in wind, solar, and battery energy storage systems. She guides organizations through transitions from fragmented systems to cohesive data infrastructures while ensuring NERC compliance. And by connecting engineers, operators, and business stakeholders, very important, she has created value through developing innovative solutions and achieving operational excellence in renewable energy. Thank you for joining us, Brenna.
Thank you.
Next, we have Cody Falcon, who is Global Digital Portfolio and Technology Leader at ABB Energy Industries. Cody leads innovation across industrial software, AI, and advisory services, and he has over 15 years in technology operations leadership. Before that, he served 11 years in the US Navy, leading submarine intelligence missions, and later served also as a White House technology advisor. And he has a BS in computer science from the University of Maryland, plus an MBA from Norwich University and multiple professional certifications in technology and cybersecurity. Thank you for joining us, Cody. Then we have Janko Izidorovic, System Architect at Fluence. Janko is a system architect and engineering leader with 19 years of experience in delivering industrial IoT and edge computing solutions. He helped lead the Linux Foundation's EdgeX Foundry, TSM, he is a TSC member, application WG chair as well, and he's contributed to next generation battery energy storage systems, operating systems at Fluence. And finally, definitely the least important person in the room is me, Hamish Mackenzie. I'm a IIoT World Board Advisor, and I'm also a former IDC analyst. I have over 25 years of experience in technology marketing, market research, go-to-market strategy, and revenue operations. And I've been running my own consultancy practice here in Munich, Germany for the last 25 years. And I help technology companies with all those aspects of go-to-market and revenue operation strategy that they need assistance with. And I really try and focus on giving those companies the focus and the clarity and the execution leverage to make sure that their complex technologies get changed into real growth, revenue growth, of course. Please look me up on LinkedIn. I'm the only Hamish in Munich as far as I know, so it shouldn't be too difficult to find me. And with all of that said, I think it's time we got started and really get into the session. So we've got a lot to talk about, and I'm going to keep this one quite open, and we're going to hopefully have a really good conversation. So I wanted to start off by going around the room and just trying to set some context really around all the around this very important topic. And I think we can all agree that industrial data is really exploding across modern grids. And so I wanted to find out from our panelists what you think is the biggest barrier to turning that data into operational value, into that insight that we need in order to create value. And so perhaps, Andrew, I can start with you. What's your view on that?
I think there's a number of key challenges that the market's facing, particularly to do with things like the heterogeneity of the data assets. There are, the wide range of different communication standards and protocols that have to be dealt with. Other challenges include things like naming conventions. So to basically to get access to this data from these complex heterogeneous systems is a big challenge. You need to be able to normalize and contextualize the data to be able to use it efficiently. So, this is where some of the key platform technologies and standards play a key role. I think we'll talk about that a little bit later, but that's one of the key challenges.
Yeah,
the heterogeneity, the naming conventions that are non-standard across equipment, never been designed to operate or interoperate together. That's a big challenge. And then obviously the potential volume of the data that's increasing on an exponential basis.
Yeah, that I've been hearing that for the last ever since the internet was invented, basically, and it doesn't seem like it's going to stop anytime soon. All right, thank you very much for that, Andrew. Cody, how about you? What is your view on this?
Well, I was trying to think of one that I totally agree with what Andrew just said. I was trying to think of a few others that he didn't mention. Look, I think the core challenge for us is not necessarily a data problem. It's more of a context problem, right? Like Andrew said, we have decades of assets, right? PLCs, SCADA systems, historians, they all speak different languages. Some of them are protocol driven, Modbus, DNP3, OPC. Some of them are proprietary, right? But the end is the raw data is out there, it all exists, but sometimes, or maybe most of the times, it comes like stripped of the context that makes it actionable, right? We may have a ton of data. We hear it often in our clients, right? We're data rich, but insight poor, right? And I believe a lot of that comes from mixing that data, blending it, making it analytics ready, and putting it on kind of a topology. So I think three things, right? To maybe, and one of them Andrew already mentioned. One is timestamp provenance, right? And integrity, right? When we start talking about AI models, they're ruthless about time, right? A 50 millisecond drift between two sensors is a big deal when using AI. Ontology, which is kind of how you map it all into a semantic layer, right? A common language for what an asset is, how it behaves, what its relationships are, et cetera. That's super important for an AI model to be able to leverage. And the third one, which is pretty important, I think we'll talk about it more later, is this edge cloud boundary, right?
Yeah.
And not everything needs to go to the cloud. And in this space, in grid and electrical power space, right, that latency is really important. And so understanding where those boundaries are and what you process on the edge, what gets summarized and what moves up to the cloud and then back down is really important from an architecture standpoint. So those would be my three to focus on.
Okay, absolutely. Thank you. And Brenna, what about you from the EDF perspective?
Yeah.
You're dealing with this all the time, I guess.
Yeah, definitely the topics that have been touched on already resonate a lot at EDF. In terms of this grappling with, like what Cody was saying, what gets, processed at the edge versus sent to the cloud. This is something that also is a moving target. It's changing, and it's difficult to predict what you might need in the future. And so the decisions on how you normalize, what you do upstream, and what you are setting up for operations, that can also change as your business evolves and your operational demands evolve. Particularly, I see, in the BESS area, if different OEMs might be operating aspects of the BESS, and as a power producer, you have a certain boundary of what you have access to, and that can shift over time as well as your service agreements change. Command and control of the fleet, I think, is another area. What the systems that we are using for that remote command and control versus data acquisition to power analytics to the business. How much can we align these systems and still stay within the compliance boundaries that we have? These are all challenges that we're facing, and as well the emerging needs and the emerging demands that continue to change.
And I think that sometimes doesn't get enough focus. Not only is this stuff complicated enough, but you have changing conditions, and we need to look at what's going on in the world right now to see that. It can be drastic changes very, very quickly. So yeah, great. Thank you for that, Brunner. Janko, lastly to you, any thoughts on that data to insight issue before we move on to talk a little bit about edge computing specifically? Oh, I can't hear you, Janko. Can anybody else?
My bad, I muted the microphone.
There we go.
So from one point of view, I agree with all the panelists. Those are the really important topics. From my point of view, one of the major thing is the amount of data, the sheer amount of data that we have on the edge, and the response times that the best systems need to have on the edge. Right, within 150 milliseconds, you have to be able to switch the whole system on and off and manage it and control it and provide power to the grid or get the power from the grid. Right, this is really challenging to create such a distributed system that is responsive, flexible, and quick.
And why do you think, and just staying with you for a second, why is edge computing becoming essential for these operations rather than just a nice to have? Why is it now in focus?
Due to regulations and stuff, quite often you are dealing with air-gapped systems that you cannot connect to, you cannot push the data to the cloud, you cannot manage those systems from the cloud. So being ability to have intelligence on the edge is crucial, and ability to control the system on the edge is crucial.
Okay.
The one more also important thing is to have a infrastructure in place that helps you push those models that you train in the cloud to the edge, infer the data on the edge, process it on the edge, and then push only what you need back to the cloud, and have those store and forward features, processing on the edge, controlling on the edge. It's really important.
Okay, Andrew, any thoughts on that edge computing particular topic? Like, why is it now becoming so essential?
I think primarily, obviously, what edge computing, what it's enabling is that kind of sub 1 second decision making. For optimization, for safety, for even things like market participation. So even if you're like Janko was talking about possibly systems which don't have a cloud element to it, but even if you have a cloud element, I think obviously for the primary reason is probably the latency. For the autonomous decision making. Closer to the grid asset, the DER. Perhaps if you do have a cloud, we do still see architectures which are a hybrid. So edge cloud for doing coordination across fleets of grid assets, DERs, but certainly for the latency challenges that we see, then it has to be done on the edge. And obviously, there's other considerations that go into this as well. If the volume of data is increasing so much that you can't, for cost reasons, for security reasons, you can't necessarily be shipping that data up to the cloud, which was possibly how things were done, in the past. So, but predominantly for low latency decision making, you have to we have to process that data and act on that data closer to where the sources of the data were in the first instance.
Mm-hmm, mm-hmm. Okay, and Cody, any thoughts on that edge computing topic in particular?
Yeah, look, I think anecdotally, when I look across our global install base, right, I can confidently say, and of course, we have the capability to deploy any of our systems directly in control on edge or cloud.
Yeah.
And I can tell you probably close to 80%, especially in the electrification and power space, are on premise, running on edge, right?
Okay.
And for many of the reasons Andrew and Janko talked about, right?
Yeah.
The closest one for us is that real-time control and closed loop operation, right? You don't have time in this space to run a decision and data up to cloud analytics and then run it back down to close the loop, right? It has to happen right next to the data. And I like what Andrew just said. We say that often, right? We try to bring the analytics and the intelligence and the AI to the source, right? And I think just a few years ago, everyone was trying to move the data to where the AI was. Now we're bringing it down to the source. So yeah, that latency thing that Andrew talked about, especially as we, in this electrical space and real-time control and closed loop optimization, that's it's super important. We have to run it on edge. And again, 80%, close to 80% of all of our global deployments are running on-premise on edge.
Okay. So so you mentioned AI there, and I want to, and we're going to focus a little bit more on Brenna and her experience in kind of the real world environments in a minute. But before we do that, you mentioned AI there, and I wanted to ask you, Cody, so when it comes to, getting this complex industrial data landscape into a common model that AI and advanced analytics can use, what are, just at a very high level, what are some of the main challenges and opportunities around that?
Yeah, I think it's the same ones we mentioned earlier, Hamish. It's mixed systems, right?
Yeah.
I think Andrew mentioned that, right? I mean, it's very common for us to come into, you're trying to aggregate from dozens of sites, right? Each site is built by dozens of OEMs and different vendors, right? If you're lucky, some of them are on some global standards, but many of them have proprietary wrappers. And once you connect all that, let's say you do bring it back either to cloud or a centralized edge in a hybrid architecture, it's a bit of a mess, right? It's mixed. Some of these things are duplicate. And how do you untangle that to get to what I would describe as a common information model, or that ontology picture that I mentioned earlier, right? Yeah. And it's really about the context for us, right? Like a voltage reading doesn't mean a whole lot unless you know the asset, its operating envelope, its position in the grid topology, what normal looks like on a Thursday at 8 a.m. in Houston, right? So all of that kind of context has to be associated with the data. And there's quite a bit of wrangling done. And I think 5 or so years ago, maybe 8 years ago, this was all done manually, right? This whole ETL process and data pipelines took a lot of time. It was more than half of the time in our projects. For today, we're kind of bringing those AI models down to the edge to do a lot of that wrangling and cleansing for us automatically.
Mm-hmm. Okay, great. Thank you for that. So let's get a bit practical then in terms of what the real world situation looks like at a company like EDF. So Brenna, could I ask you first of all, how do you even go about making decisions about what kind of data infrastructure to invest in?
Yeah, it's a complex one for sure. We had started with a business capability mapping exercise where we tried to really understand what were our current operational needs and how did we perform against those, so that it was driven by what are the needs in the business rather than just what might be available, because there's going to be a lot of different ways to solve these problems. And starting with that, we had to look at what was our strategy alignment. And for EDF, it was really important to have visibility across not only our North American fleet, but our global fleet as well. And the kind of data sovereignty, or our ability to control our data. So that led us to deploying some in-house solutions coupled with vendor solutions as well. But we really used some close collaboration with business users, with our SCADA engineers, to really understand end to end what this system needed to do and needed to accomplish for the business and how it was going to run day to day. You have to weigh a lot of trade-offs too with the upfront costs versus your run costs, and this is one of those somewhat of a moving target in terms of how do you tackle the problem of looking ahead and setting yourself up for the future. And this helped us align to we have a large and varied fleet across solar, wind, and storage and hybrid sites as well. So we are, I would say, a good way through our transformation in this effort. We've deployed an edge solution across over 50 of our sites, and we still have, I think it's at various stages of maturity now that we're seeing. So we have consolidated a lot of that data acquisition to we went with the IEC 61850 standard. So that has helped us normalize across all of the different OEMs. But we're doing that up front. And so, that takes investment up front. And then again, as emerging questions come out from our fleet engineers about a new problem that they need to troubleshoot, if that's not something that you've, tagged up front, then it's the challenge to go back and normalize, another new set of data. So, but it's definitely helping us give a better view across our assets to provide that layer of intelligence, because indeed it did take a lot of time to normalize across all of the OEMs. So we had to look at it through that business lens as well as what is the best fit from a technology perspective, and also the actual cost of change to the business. This has a big human impact. It's a lot of complex systems, but it's teams of people, and so that's a lot of organizational change that you have to manage through as well.
Yeah, absolutely. I think that's one thing that sometimes gets a bit overlooked in these discussions, because everybody's talking about the technology and we forget that still, who knows for how long, but there's still a lot of people in the loop at the moment. So important not to overlook that. What about one capability or requirement that maybe is underestimated usually you underestimated perhaps when evolving that data infrastructure?
Yeah, like I was referring to, we had this challenge to, we had a central edge historian on-prem, and the business users were able to really access this from a lot of different angles. And so we were finding that people were, developing their own analytics, and there was probably a lot of duplication of effort going on. And so we're, unifying into a stronger data pipeline from the edge up, through the cloud to our analytics spaces. But really, what we're finding is then that becomes a more complex, chain of the data transformation process happening. And so, to really think ahead and have that clear picture of what is going to be your data governance model, who are the owners along the chain, and how do you control and support new requests from the business, from your systems, that's been a challenge. So you've kind of democratized the access to data, but through that change, it can still be difficult to have that clear data quality and a unified. Now you have more dependency on that single chain, and so that can be challenging. So I'd say designing with the end in mind and really thinking about that day-to-day operational model of when things break down, how are you bringing it back online, and what's the return to service or return to order. That's something to really keep in mind as you're also designing, not just for maybe your target solution that might fit your technology needs. The other piece around normalization is that it's great to have the standard, but you also still need to have the business naming that is understandable by a variety of different business users in your control room, in your engineering fleet, and out at your sites. So a lot of different factors to kind of consider upfront.
Yeah. Okay. And lastly, just in terms of the specific challenge of integrating data from various sources, battery, solar, wind, etc. Are there any specific challenges we haven't covered that relating to that in particular?
Yeah, and I'm sure this is something, Janko, you can probably speak to as well. In terms of our, I think we see the greatest maturity in terms of our wind and to a degree our solar fleet. Batteries really emerging, and for us, one of the biggest challenges has been, again, as our role and our goals around how we are operating the batteries, how we're participating in the markets. Sometimes your entire commercial agreement can also change with an asset, and so your operating model has to change along with that. For example, if you're having to now operate the balancing of the battery, that's requiring a whole different depth of data. And so taking that on, we've had to take that on for some of our fleet, and that provided a huge learning challenge to try to understand how well our data could, our existing, what we had tagged already, how much we were able to leverage that versus where we had to go directly to the SCADA system, and now making those decisions of, okay, what do we want to bring in as our standard? What do we want to automate in terms of our ability to operate some of these balancing controls, and you have to get much further down into the asset at the cell level to be able to run the operations effectively. So I'd say battery, especially also because the market is changing, and you have new participants, new technology. It's changing so much more quickly as well. To try to bring that into a standard, that's probably the most difficult part we see in our fleet.
Okay, Janko, any thoughts on that?
Yeah. So when we talk about batteries, the amount of data that we ideally would like to have is really enormous. Keep in mind that battery cell is the size of a cell phone, right? And approximately. And then one battery enclosure is basically the size of a shipping container. So you can imagine how many cell phones you can put in a shipping container. And for each of the cells, you need to have the state of charge, state of health, right? And ideally, you would like to have that every second, every 10 seconds or so, or if it's charging, discharging, even at higher frequencies. And you might have thousands of containers on site. So the amount of data is enormous. The grid requirements are very strict, and you have to obey them, and they might change in time. So you have to design a flexible system that in the future can adapt and comply to the future regulations. So having a flexible system on the edge is really extremely important. Another thing is when you design these systems, you have to keep in mind that they are designed to run for 20 years, 25 years, right? So we have, in time, you will have devices break on those sites. In 10, 15 years, you might not be able to procure the exact same device. For sure, even if you get the same device, it will not have the same firmware, right? So having ability to provide the context with data, both to the edge so that you can process it on the edge fast enough and control on the edge, and then summarize it, downsample it, push it to the cloud with the proper context, where you have the same function, more or less the same device with different data sets, because one is 10 years old and the other one is brand new. That's really a challenge from engineering standpoint.
Okay, fantastic. All right, so Andrew, I'd like to hear from you. Does what Brenna was just talking about there, does that gel with your experience as well? And also, because we're talking a lot about standards now at this point, how do standards help solve these interoperability challenges?
Yeah, well, that leads in really nicely. So first of all, from our perspective, so we provide edge software infrastructure to support vendors and operators build these DARs and stuff like that. Yeah. So from a philosophical point of view, we have to provide technology which is extremely flexible to support the systems as they evolve, to be able to allow them to be updated and change. So from a we have to build in characteristics that support that. So both at the functional and non-functional levels, the things that what we focus on as a platform vendor are being able to support the scale. So being able to horizontally scale out the platform technology, because the systems that we do can vary vastly in terms of the amount of data points, the changing messages per second. We have to be able to support lots of different form factors of equipment that's in the environment. So having platform independent software, so you can run it on very small, say, edge gateway, ARM-based data acquisition units, or in a federated architecture, you may have to put an integrated, integrate the data access with the control systems which are running on server class devices within the same environment. So the scaling, is very important, and the ability to run on lots of different equipment. But also particularly from an evolvability or how your system moves forward, having an open architecture approach to the software infrastructure, I think, is very critical, and that brings in standards as well. So to allow standards support interoperability, and that's one of the key things in these types of systems, because the assets and stuff were never really designed to work together. So standards provide a common language to allow you to integrate the assets together. And it supports things like plug and play, said interoperability. So building these facilities into the platform technology so that you can normalize the data as you're taking the data off lots of different types of equipment, lots of different protocols, and you may normalize that data based on different standards. Some cases we normalize it into things like MQTT Sparkplug for large distribution across components within the system. And then perhaps that's remapped into something like OPC to provide an interface for other components of the system, whether it's the SCADA systems or there are UIs and things like that, to be able to be integrated in. So I think standards, the standards are critical. Open architecture approach, standards-based approach, they support particularly interoperability. They give customers, the vendors, the operators, flexibility of choice. It prevents vendor lock-in, makes the integration phases of the project a lot easier than proprietary APIs. And also, as I said, the systems are increasing in scale all the time, and then the ability to coordinate across fleets of assets is becoming much more a thing that the operators want to be able to enable. And again, standards-based communication infrastructure supports those different types of emerging requirement.
Yeah.
The final thing I would like to say as well is one of the other key things is fleet scale orchestration. So Brenna touched on the ability to basically say add new data tags or new assets into a system. So I think there's another layer on top of the data layer that's very, very important. You need orchestration on top of these systems to allow you to push updates into the system at fleet scale. Otherwise, the systems become unmanageable. So that's like another key aspect, I would say.
Mm-hmm. Okay, fantastic. Thank you for that. And I want to move increasingly more towards the AI direction now. And so, Cody, obviously, as Andrew was alluding to, there's a mixture of older physical asset infrastructure and there's some digital native infrastructure. How do you help operators manage that, but also at the same time enabling that AI-driven insight and the move towards even more autonomous operations?
Yeah, and before I jump into that one, just to I want to maybe give Brenna a shout out here. It was awesome to hear her from an end user perspective talk about enforcing standards from incoming vendors.
Yeah.
Right? And so that's really who drives these standards, right? So thinking about that up front, if you're doing vendor selection and putting together a new asset or a new site, you're bidding process should include compliance with 61850 or whatever the standard you want to use is. That makes it a lot easier for the vendors once they get in. So thinking about that up front is super important. And I think standards are driven from the buyer side, right? From the end user, and forcing their vendors to comply. So back to the AI topic. Can you repeat it one more time, Hamish? The question was around.
So we've got all this very diverse mix of infrastructure, right? Which you need to help the operator manage, but you also want to make sure that you can leverage AI to drive the insight from the data and help the operators enable even more autonomous operations. So how do you go about doing that?
Yeah, I mean, that's the world that my teams and I spend a lot of time in. It's the brownfield world, right? I think Jaco mentioned it. I mean, our control systems and our electrification systems are designed for 20 to 30 year lives, right? And so we're typically going into brownfields. And, the way that I think about it is that you don't necessarily need to modernize the assets. You just need to create this translation layer around them, right? So if I think about a 30-year-old transformer, it's not a firmware upgrade. It needs a smart sensor and an edge gateway that makes it look to an AI system like any other data producing asset, right? An AI model doesn't care if it's 30 years old and couldn't connect versus if it just came online 2 months ago and was designed for AI, right? So I think that's the architectural shift that we see. It's like, we don't think about the asset age and the legacy stuff. We start thinking about the data equivalence, right? How do we bring it up to speed in a retrofit? And we typically do it in kind of a prioritized order, brownfield instrumentation first, right? Retrofit where you can, vibration sensors, thermal imaging, current signatures. Don't modernize the asset. You're just adding observability. And so the asset maybe stays dumb, but your edge gets smart, right? And then the second one is this kind of unified data abstraction layer, right? Your AI models, again, they don't care whether the reading came from a brand new digital relay or a legacy RTU with a protocol translator bolted onto the edge, right? The semantic layer normalizes all of that stuff on the same ontology, like we talked about earlier, same feature pipeline, regardless of the asset edge, right? And so I think the biggest mistake that I see here, Hamish, is like, some of our clients think about this as a binary switch, right? It's either modern or it's legacy. That shouldn't be the case, right? So we think about it kind of on a continuum, right? Every asset is on a bit of a spectrum from data dark to autonomous. And, we retrofit these things, these legacy assets in a prioritized order to just get the data that we need out to solve the right problems. And one more thing, I just reflected on what Brenna said earlier, right? Thinking from the end state backwards, right? We often talk about kind of working backwards from the problem set. I will tell you, we see it quite often. We'll come in into some of our clients, right, that have been down the consulting road, and they're focused on building massive enterprise data lakes and trying to collect everything. That shouldn't be the starting point, right? The starting point is, what are your top 3 problems, your top 10 problems and use cases, and then moving backwards and kind of backing into the sensors, the retrofit, the data that you need to solve the problem, instead of just collecting data in the hopes of using it.
Right.
Yeah, I would echo that as well, for sure. You can talk to a lot of different engineers who want everything. When I ask them, well, what's the depth of data you want? Why I want it back to COD? And I understand that, but I think it's solving for identifying what is actually the challenge that you're facing. How can you quantify what's the impact that's having on your business, and using that to prioritize, bringing that rigor in as well. That's a key part of what I do and our team does is helping to prioritize through those decision points, because that's really important. What are we looking to get from that sensor? What are we going to learn from that? What action are we going to take from that? Not just, well, we want to know what's going on. I think that's a really important point.
A quick horror story it actually just happened a few weeks ago, right? We were sitting with a customer who had built over 5 years, had $100 million enterprise data lake, right, put in place, where they were collecting everything in the organization. So we just backed up and we talked to operations, and he said, what's your primary problem affecting the business? And it wasn't power related. In this case, it was heat exchanger fouling and issues offshore. right? And we said, well, what if we told you that your heat exchangers have 28 tags, and to predict fouling, we only need to look at 5, right? You probably don't need $100 million, 400,000 tag real-time system in place to be able to fix your number one problem. So back to Brenna's point, kind of identifying it up front and working backwards. And, maybe over the course of 5 years of solving real problems and delivering value, you'll wake up and you have all of that enterprise data, but that shouldn't be the starting point.
I'm very pleased. I'm laughing because I'm very pleased that this is reflected in all sorts of other areas as well. So lots of clients come to me and say, we need an AI strategy. And the first thing I say to them, well, we could sit down and 6 months and create a big fancy AI strategy for you, but what I'd rather do is, what are your 3 biggest problems right now in terms of revenue generation? Okay, let's look at those. How can AI help? We'll run a pilot, get some results, and then we'll go from there, right? So it's fascinating that it's the same kind of scenario. Okay, so I want to ask Brenna to kind of show us behind the curtain a little bit in a minute in terms of what they're doing, what EDF is doing in terms of testing and deploying AI. But before we do that, what does it actually mean for a DER flight to be AI ready? I don't know. Maybe Andrew, you want to answer that first?
Yeah, I think there's probably a number of aspects to that. I think probably 3 core elements to it. Mm-hmm. I think you need to have high quality time series data, normalized time series data to drive the AI high quality. I think you need to have consistent semantic tagging of the data. And then probably the third thing is the compute at the edge to actually run the models. So they're the sort of 3 core pillars of enablement. And then perhaps, in terms of what if you've got that, then you can run your AI models at the edge. But then obviously I think the other thing after that is basically the orchestration side of things. In the life cycle of your AI, you need the mechanisms to be able to deploy, update, monitor, roll back your AI. So I think that the first 3 about having high quality time series data, the consistent semantic tagging across the data sets, and having the compute to actually run the AI are the 3 core pieces that you need to have in place.
Okay, fantastic. Thank you. So I realize we're already 40 minutes in, so I'm going to have to speed up a little bit, otherwise we won't get to any questions. So Brenna, if you could just give us a quick insight, please, into how you are, as I mentioned before, how EDF is currently testing or deploying AI to leverage that data infrastructure.
Yeah, it's part of it is just as Andrew described. The the effort to deploy this standardization. That's really laying the groundwork for many future capabilities and use cases that we might try to tackle. But that aside, where we are experimenting right now, again, it's really business driven, and for us, we're taking keeping the human in the loop is really important. We've tested out, like I said, with the challenge of onboarding an asset, getting an asset completely set up and configured. That's one area where we've been testing to see how well an AI model can help us configure a site. And when you have multiple OEMs and you can train a model pretty well, it works pretty well. Then you still need to have some refinement. You still need to take care with how you're mapping maybe the substation or something that's really specific. But it can help you in scaling in that productivity aspect. We're also looking at some areas where it can help with troubleshooting models. So now we have all of these service records combined with what's happening in the moment with the asset, helping to bring those into more of a contextualized troubleshooting guide. That's an area where we can see a lot of value, bringing new operators up to speed, being able to leverage that data. But again, here's your top 3 things that you might want to try next. but we're not to the point of automating that decision yet. I think it's still too early days. But again, those are a couple of examples where we've seen there be a real use case in our business that we're trying to solve, and it's one of the tools that we're trying to deploy. But again, really, I think there's so much more growth because just getting that kind of the bedrock of your data infrastructure ready, that's gonna allow us to do a lot more in the future too.
Okay, fantastic. So I'm gonna skip forward a little bit just so I make sure we get time to talk about the future a little bit in a minute, and also get to some questions. But sticking with kind of, because our audiences tend to find that the kind of real world aspect most valuable and most interesting. So I'd like to just go around the room quickly and ask each of you if there's one kind of lesson from a real deployment, either specifically in relation to changing the way you thought about the edge data infrastructure, or any other kind of real world deployment example that you think is really important within the context of everything that we've been talking about. Does any of you have a particular example in mind? Just kick us off.
Yeah, we've seen if you're talking about practical experience of things that you need to we've seen in the edge environments, things like we've seen problems because you don't have your timestamp accuracy. So coordinating timestamp and across a set of distributed nodes within the edge has caused problems in the control. So synchronize the clocks so that the timestamping for all the data is accurate is one of the issues that we've encountered, practically speaking.
Mm-hmm.
And I think some of the things that people don't necessarily think about up front is the importance of things like data reduction within the system, data reduction strategies. So things like filtering and compression and unchanged semantics. As you scale up, these things become much more important. So there's things like that we've learned through experience that the operators need, and we, for example, as a platform supplier, we have to build these capabilities into the platform to allow the data to be not just accessed but optimized on the network in terms of because the sheer volume you can't ship around all of the data points that you may be accessing, and in most cases you don't have to, because you only have to ship data around if the values are actually changing, and those are practical strategies that we use in real world deployments to try and optimize the network bandwidth and manage the data more efficiently.
Okay, thank you very much for that. So Cody, you've already given us one kind of real world horror story, but did you have any other best practice examples or lessons learned from any recent deployments?
Yeah, maybe something just to think about, right? Specific to edge. I mean, as you know, we have a large global edge base all around the world, and for us, oftentimes life cycle and support is overlooked. I think two things are overlooked, right? When you decide to put an on-premise lights out edge on site that's completely disconnected and no one can touch it, you have to think about things like software updates, patching, security controls, etc., remote support. And so sometimes I see clients call and say, hey, what's going on at this specific model, to Jaco's point? Maybe there's models running down there on the edge. Well, if we can't touch it or can't see it, it's difficult to support that, right? Maybe I could fly an engineer in country and take a look. And so thinking about that life cycle support level in disconnected lights out environments. And then the second one would be, and it's kind of on the connectivity track, right? The benefits of fleet-wide connectivity, right? I mean, it's similar to self-driving cars, right? You have the option to only use the data from your car, but it's a fraction as good as if you opted in and shared data with the fleet and you get the wisdom of the crowd, right? Yeah. So thinking about this hybrid model that Andrew mentioned, right, where you do have some connectivity and can connect and leverage, several 100,000 other users' knowledge, right, in a secure, anonymous way to benefit you versus just on your island, your site, or maybe just your fleet.
Right. Fantastic. Janko, any real world stories from your perspective?
So when you have large distributed systems on the edge, basically you are putting a lot of things on the network itself, right? And in the energy sector, you're having your network cables straight next to the 10 megawatt battery source. So taking care of network, making sure that it's free of noise, that it's reliable, that's one big thing to think about. And we usually take that for granted because networks kind of usually just work. Well, it can be a problem.
Okay, excellent. So because of time, I think I'm gonna move on to the final section now before we get to questions, and I want everybody to get their crystal balls out a little bit, and perhaps talk about how you see edge intelligence shaping the future of grid modernization over the next 5 years. And I know it's very difficult, particularly now, and probably will get even more difficult in the future to predict that far out because things are evolving so quickly. But I'd just like to go around the room and get everybody's perspective on that. So maybe Brenna, starting with you, how do you see things, particularly in the context of edge, evolving over the next 5 years for EDF?
Yeah, I wish I had that crystal ball, but I would say, I'd love to see this have a big impact on safety. Anytime that you can keep somebody out of the field or out of harm's way is going to be a really important business driver, and it is for us, already in our operations. But the ability to have preventative measures prevent, catastrophic events or even, issues on site. This is by having control at the edge or analytics and decision making. I'd love to see a bigger impact there. This would be a huge gain, I think.
Okay, Janko.
We did not speak much about security at all, and I think when you have an edge system, in energy sector, those are usually closed environments, and you have your barbed wire around the premise and stuff. But still, security needs to be tied tightly into the system, and especially if you don't have connectivity to the cloud and it's autonomous. So building edge components and edge system that is secured by design is really essential.
Fantastic. All right. Thank you very much, Janko. Cody?
Yeah, just a quick one, right? I see the shift. Earlier, I mentioned 80% of our power generation deployments are on edge, right? I think that's the shift over the next decade. It's not a brain in the cloud. I think we will realize we have thousands of brains running on edge, right? That's where I see the future growing. I think it's smarter because not because we have better software in the cloud. It's smarter because the intelligence is embedded on the on-ground infrastructure. Right? That's
okay. Thanks, Cody. And finally, Andrew, what's your crystal ball telling you?
I think at the sort of highest level, intelligence is going to enable the DERs to behave more like fully coordinated grid supportive assets, as opposed to just isolated islands of devices. So I think that's going to be you're going to get that's going to enable this integration and more autonomous behavior. Fleets, best fleets will be able to self-optimize, and DRs will be able to take part in markets without necessarily having humans in the loop. So I think that's sort of the future direction.
Fantastic. All right. Thank you very much, everybody, for that. We do pride ourselves at IoT World on the fact that these events are live, and we take live questions. And we do also try to ensure that even if we don't get to a question, we get a response to people who ask at the end. So I'd like to use the last 5 or 10 minutes now to tackle some of these questions that have come in. So another thing, Janko's right, we didn't really talk much about security. We also didn't really talk much about cost yet. And so one of the questions has come in and said, how do you see the cost factor for deploying an edge software platform? Are the current digital technologies and running AI inferences on edge making it difficult to adopt, operate, and maintain over a long time, and and the costs associated with that? So I don't know who would like to tackle that cost issue. Brenna, do you have any thoughts on that?
Yeah, I mean, this is really central. There has to be a business case, and there has to be some sort of a payback. So when we're looking at what are we aiming to get out of this? Is it productivity? Are we looking at additional revenue because of a new market we can participate in? There has to be really a bottom line driver for this, and that's something that it definitely comes into the picture when we look at our technology assessments. That said, there's going to be trade-offs, right? And there's also trade-offs between what is your upfront costs and what are your run costs, and how much might be hidden cost in your organization that you're already paying that is not that you can look to offset. So absolutely, it's a huge factor in our decision making, and I'm sure many of the customers, Cody, that you and Andrew serve.
Fantastic. Anybody else want to chime in on cost?
Yeah, I think, as I said, as a vendor of the edge infrastructure, we're looking at it from a point of view of trying to enable this in a cost-effective way. So by having edge technology that supports sort of plug and play AI, so you can have your own choice of there's lots of different types of AI and different types of models that you can plug into the platform. Get these are data-driven components. Get that time series semantic tag data very easily, and then the mechanisms to support the life cycle of the AI. I mentioned things like the orchestration, updating, rollback, monitoring of the AI to determine whether it's behaving properly and stuff like that. As I said, providing that infrastructure that allows people to do it with as least friction as possible, obviously encourages its use, enables its use, and then I think that'll drive down the cost of operating AI technologies in these environments.
Okay, fantastic. Thank you. Okay, so another question now. So as grids become more decentralized, what best practices exist for ensuring that predictive and autonomous controls at the edge don't compromise safety or compliance?
I'll take that one to start with. Yeah. I think to start with, you have AI in the loop, but not in control. Safety critical systems are designed and certified, using standards and compliance. And at the minute, as I said, AI is, in the future, AI may be used as part of autonomous actions within a system. But at the minute, what the AI is good at is doing things like fault diagnostics, predictive analytics. It's good as an advisory thing. I think the rollouts we see at the minute is that people are using AI models in a very constrained way. It has to be, as I said, the potential for taking actions that are not necessarily predictable is a key issue with ML and different types of AI, particularly as you start to see agentic AI used. So I think to start with, as I said, for supervisory, advisory, optimization recommendations, fault diagnostics, and particularly with human in the loop checkpoints. In the future, I think as the technology and the use of them becomes more well understood and how you develop and operate these models, you may start to get AI used in more critical functions, but that's the future. That's not now. So safety critical systems are not using AI at this point in time. Yeah. And you have to treat your AI as a potentially a safety critical, could introduce safety critical issues. So you need to look at it very carefully.
Okay.
I would just add to this, if you look at the other domains that are also highly regulated, like banking and similar, we can see that there are some AI, like explainable AI things, where you use AI to generate the model, but the model has to be explainable, and and the human should be able to understand why the model behaves as is. And if we have such a thing, then we can push that to a control loop and be sure that we understand what is actually happening. So AI should not always be a black box. The models that AI creates should be explainable to humans.
So these autonomous closed loop systems, right, is what we're really focused on. And I think Jaco and Andrew just hit it, right? I mean, explainability is one piece of responsible AI practice. And what Andrew said, right, your safety and design limits are the ultimate guardrail, right? So even when we are running agentic in safety systems in closed loop control, right, there's a guardrail, which is your safety and design limits, right? It's not going to run wild, and something that I have to remind our hyperscaler friends all the time about, right? What we're doing with agentic workflows and industrials, right, in closed loop is worlds apart from Copilot and Outlook helping you sharpen an email, right? And so these are two very different worlds, and sometimes it feels like we're a bit behind, but we're intentionally slow because of the risk profile that Andrew mentioned.
Fantastic. All right, thank you, guys. Well, I'm afraid we are out of time. As always, we could go on for another hour, I'm sure, but we aren't able to do that, unfortunately. So I'd just like to thank you all for your great insights. Thank you particularly for IoTech Systems for sponsoring the session. Without that, we wouldn't be able to run these events at all. Thank you to our audience and the great questions you asked us. We will come back to you with answers for any that we didn't get to during the session. It's now time to move on to the next session in today's event, which is Scaling Virtual Power Plants, Data Challenges at 100,000 plus Distributed Assets, sponsored by Influx Data. So again, thank you very much. I hope you enjoyed the session, everybody. And I'll see you again later in my next session, which is in an hour's time. And enjoy the rest of the day. Thank you.